Okay, so for these examples, we are reminded of a few properties for our logs. If they have the same base, then you can rewrite log of that particular value plus log of the other value as multiplication, or vice versa. You could rewrite multiplication as addition. Same rule for subtraction. If they have the same base and they're written with subtraction, you can rewrite them as division, or if given to you as division, you can rewrite as subtraction. Okay, and our third property is if that value that you're taking the log of has an exponent, you can take that exponent and rewrite it out front as a coefficient. All right, so keeping that in mind, let's look here at example 1. Example 1 says use the log properties to expand. So we can see here for part A, these two terms are right next to each other, which implies multiplication, and we know multiplication can be rewritten as addition. So I'm going to have log base 7 of A to the 1/2. I'm just going to rewrite that square root as the fraction 1/2 plus log base 7 of B squared. So we expanded with addition. I also can take these exponents and rewrite them as coefficients. So this would be equivalent to 1/2 log base 7 of A plus 2 log base 7 of B. All right, for part B, we have some division here. So for the division, we can rewrite as subtraction. Also, this is all under a fourth root. So I'm going to actually rewrite this as ln of x over 5y squared raised to the 1/4. Okay, I can take that 1/4 and rewrite it as a coefficient. So I'll have 1/4 times every single one of these is going to have that coefficient. So I'm just going to put them all in a parenthesis. So I'm going to have the natural log of x, and then we've got division, so minus the natural log of 5y squared. That 5y squared, however, is two terms being multiplied together, so I could actually expand those using addition. So that'd be ln of 5 plus ln of y squared. Now at the same time, I could take that 2 and write it as a coefficient. So I actually would probably write this as 2 ln of y. Now, if I need to simplify, I would need to take this negative and distribute it into the parenthesis here. So I'd have 1/4 ln of x. When I distribute this negative here, it's just negative ln of 5. When I distribute it here, it'll be negative 2 ln y. Now, this would be a perfectly acceptable answer, but I also am welcome to distribute the 1/4 to each term if I prefer, which would then look like 1/4 ln of x minus 1/4 ln of 5. And then if I distribute the 1/4 to that negative 2, that one would actually be negative 1/2 natural log of y. So either this or this is an acceptable answer. All right, for part C. On part C, looks like we've got a log base 3 for this entire problem, so I can separate. Looks like these two terms are multiplied together, as are these two terms. And then they're separated by this subtraction piece. I wouldn't want to expand this one out with the addition, because then that is going to have the person reading it assume that it was division to begin with, which we don't want to happen. So I'm just going to keep it as these terms, but this square root I am going to rewrite as an exponent. So this would be log base 3 of 4b squared minus 5a to the 1/2. Again, I don't really want to break those up because what that means is that they're going to assume that with this subtraction in there that at one point it was division, but it's not, right? This is all one piece. What I can do is take this and bring it to the front as a coefficient. So I'd have 1/2 log base 3 times 4b squared minus 5a. All right, so now let's talk about condensing. So these do all have the same base, so we can use our rule from up above. So I have log base 6 of my first term here has a coefficient of 5, which means that q originally had an exponent of 5. And then we've got minus, which would mean division. We've got a coefficient of 1/2 for that r, so that's r to the 1/2 or the square root of r. And then we've got plus, which means multiplication. Coefficient of 4 would be s to the 4th. All right, for part B, we have that common log base 10. But we do have this exponent of 1/3, which tells us that this entire problem has an exponent of 1/3 or a cubed root. So then I look at my first term, exponent must have been 2, so we'd have w squared. Plus means multiplication, no coefficient, so just times x. Minus means division, so I'd have the 5th root of z in the denominator. All right, for part C, this one is the natural log. It is all raised to the 1/2 or under a square root. We'd have a minus b plus, this tells me c had an exponent of 5, so multiplication now. Minus means we have division, and we've got 1/3, so a cubed root of d. All right, on the back. Before we start simplifying, it reminds us that with compositions of functions, when you are taking compositions of an inverse and its original function, that these always simplify down to just x. Because if you remember, these are basically operations that are undoing each other. So we are going to keep that in mind when we have a log and an exponential function with the same base. Remember, those are inverses of each other. In other words, they undo each other. So here, this is understood to have a base e. So here, ln of e, the natural log of e, is just 1. So this becomes 1 to the x. So in other words here, x would be equal to 1. Okay, this one's a little bit different because ln is the base. Okay, if you were to type the natural log of e in your calculator, it becomes 1. So that is why this one's a little bit different, right? You would think maybe it should just be x because that's what's left over, but if you were to type this in your calculator, you get 1. All right, so part B, written in the reverse order, but same idea, your natural log and that e should cross out, so we are simply left over with x. On part C, your natural log, again, this is understood to be base e, all of this will cross out. All I'm left with is 10. So my solution here simplifies down to 10. All right, this also works for any base that matches the term. So here I've got a base of 2 and a 2 here, so those basically undo each other or cancel each other out, and I'm left with z. Okay, and then we've got log base 8 and 8. So those are going to cross out. I'm left with 5z. For part F, This one, we do need to use one of those rules that they went over on the front. There was a property that said if you have a number in front of a log, like we do here, so if you notice, this one was not in front of a log, so that's why we didn't have to do it on part E. The 5 was just in front of a variable z, not in front of a log. But that we can pull that over here as an exponent. So this would be equivalent to e raised to the natural log of x to the 5th. Now, just like before, this is going to go away, so I'm left with x to the 5th. All right, same thing for part G here. This would have originally been an exponent, so this would be 7 to the log base 7b to the 1/2. So this part goes away. I'm left with b to the 1/2. All right. Here, for our laws of exponents, remember, laws of exponents say that if you multiply common bases, you add them. Well, they're adding these exponents, so that must have meant that they had the common base of 10 and were being multiplied. So this really could be rewritten as 10 squared times 10 log of 3. All right, remember, common log says this must be a 10 if it's not actually there. So this part would go away, and I'm just left with 3. So I'd be left with 10 squared times 3, which would be 300. All right, same thing here. This addition here, laws of exponents say that means it was a common base being multiplied originally. So e to the 3rd times e to the 2 ln of 5. That 2 can become an exponent, so I'm going to go ahead and write that as ln of 5 squared. So here, understood base e, so those cross out, I'm left with e to the 3rd times 5 squared, which would just be 25 e to the 3rd. All right. For this section, we are given log base 3 of 4 and log base 3 of 7. So we're going to want to rewrite these as things that, as these terms so that we can replace them with these decimals to simplify. So I know I can rewrite 28 as 4 times 7. So this would be log base 3 of 4 times 7. And according to our properties on the front, I can expand that into addition. So I'd have log base 3 of 4 plus log base 3 of 7. And now it matches what we were given, so I can replace. So I'd replace log base 3 of 4 with the decimal 1.262, log base 3 of 7 with 1.771. We add those together, we get 3.033. For part B, this one is already written in terms of 7 and 4, so I just need to expand. Division says it can be rewritten as subtraction. So I'd have log base 3 of 7 minus log base 3 of 4, which I can replace with 1.771 minus 1.262, which would be 0.509. For part C, 49 can be rewritten as 7 squared. So I'm going to rewrite this as log base 3 of 7 squared. Remember, you can take an exponent and rewrite it as a coefficient. So this would be 2 log base 3 of 7, or 2 times 1.771, which would give me 3.542. All right, and then for this last one, this one we got to think a little bit harder. Only the 4 will go into 12. And 4 will go into 12 3 times. Well, lucky for us, we are a base of 3. So I'm going to rewrite this as log base 3 of 3 times 4, which can be expanded into log base 3 of 3 plus log base 3 of 4. And this basically undoes itself, right? Remember, we're saying it cancels out. That means it divides out. Anything divided by itself is 1. So this is 1 plus, we'd have 1.262, which would give us 2.262. All right, same thing in this last section here. we've got log base A of 5 equals 3, log base A of 8 equals 10. So I'm going to rewrite this as log base A of 5 times 8, which is log base A of 5 plus log base A of 8, or in other words, 3 plus 10, which is 13. Part B is already written with an 8 as its term, so I don't really want to get rid of the 8. I'm just going to rewrite that square root as an exponent of 1/2, which can be pulled to the front as a coefficient. So we'd have 1/2 log base A of 8, or 1/2 times 10, which would just be 5. And then lastly, we could rewrite this as log base A of 5 squared. Again, you can pull that exponent to the front, so I'd have 2 times log base A of 5, or 2 times 3, which would give me 6.